Hi everyone, today we will discuss the different features of ARM processor and its architecture. A Corn Computer Limited situated at Cambridge has given the concept of ARM processor. It is called as Advanced RISC Machine. It is a 32-bit microprocessor, so it is not a processor, it is an idea. Means it is a core licensed to many manufacturers to build the different versions of ARM. Now let's discuss the different features of ARM processor. The first feature is that ARM processor is having a 32-bit microprocessor. Being a 32-bit processor, it is a 4 times as powerful as 8085. As we know that 8085 is a 8-bit microprocessor. So in case of processing, 8085 process 8 bits in one cycle. But in case of ARM processor, it processes 32 bits in one cycle. So this is in case of 8085 and this is in case of ARM. Next feature is that ARM processor is having arithmetic logical unit of 32 bit. What does it mean? That it can perform the addition and subtraction of 32-bit number in one cycle. Next feature is it is having a 32-bit data bus. Now what does it mean? That it can transfer a 32-bit in one cycle that we've already discussed in first point. So in first point we have compared ARM processor with 8085. If we'll compare with 8086, now 8086 having 16-bit data bus, so it can process 16 bits in one cycle. That's why we have divided the memory into two banks in case of 8086, that is odd bank and even bank. Now in case of ARM processor, so here the data bus is of 32-bit, but in one cycle we can process 8-bit. So if we want to process a 16-bit in one cycle, then we need to have a database of longer bits. Now here we have to process a 32-bit in one cycle. So here the memory segmentation is done in such a way that it can process 32 bits in one cycle, like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So the first address should be multiple of 4. Then only it can process a 32 bit in a single cycle. There is a concept of aligned and misaligned data. If the data start from the multiple of 4, then it is called as a aligned data. In case it starts from other digit other than the multiple of 4, then it will come under the category of misaligned data. Now, normal processor like 8086 put both the data that is aligned as well as misaligned data. Aligned data will require one cycle, whereas misaligned data will require two cycles. But ARM does not allow misaligned data. Why? Because it is a performance-based processor. So it should start from 0, 4 or 8 or C, that is it should be a multiple of 4. Next point is it is having a 32-bit instruction, that is RISC based architecture. What does RISC means? reduced instruction set computer. RISC processors are performance-oriented processor, whereas CISC processors are flexible as compared to RISC architecture. So these are not a rigid architecture, but RISC architecture follows the principle of rigidity. Means that the main advantage of RISC architecture is that all instruction is of same size, which infer that every instruction will be exactly taking the one cycle to execute, which will give the high performance. It also infer that it will follow the proper pipelining process. Why? Because every cycle is taking a fixed size instruction. So in case of ARM processor, every instruction is fixed of 32 bits. Next is it is having a 32-bit address bus. Now what does it mean? If it is having a 32-bit, 2 raised to power 32 means it is approx 4 GB. So it can address up to 4 GB memory. Next feature is it follows the principle of von Neumann model. Now there are two models of processor exist. First one is Harvard and second one is von Neumann. In von Neumann, only one memory exists which contains the programs as well as data. But in case of Harvard architecture, separate memory for programs and data exist. So in case of ARM processor, it follows the von Neumann model in which there is a common memory for program as well as data. The important feature of ARM processor is that it follows the concept of pipelining. So it follows the three-stage pipelining: fetch, decode, and execute. Like in first cycle, it fetch the instruction. In the next cycle, it will fetch the next instruction and decode the first instruction. In the next cycle, it will fetch the third instruction, decode the second instruction, and execute the first instruction. So similarly, the process follows: fetch, decode, execute, fetch, decode, execute, fetch, decode, execute. Next is that ARM processor contains the total number of 37 registers, which is a huge amount. The complete architecture of ARM processor follows the load store model. Now, what does load store model indicate? That every operation performed in registers. No operation is allowed to perform in memory. It is based upon the concept of load and store. First, we need to load the content in register, then operation will be performed in the register, and after that we can store the result wherever we want. That it can be stored in the memory, or if we want to store it in the register, then we can store it in the register. So it follows the load store model strictly. ARM processor is having a 7 operating modes and 7 interrupt exception modes. In case of 7 operating modes, there is a user, FAQ, IRQ, supervisor mode, abort mode, undefined mode, and system mode. And 7 interrupt are, or we can say exceptions are: reset, software interrupt, undefined instruction, prefetch abort, data abort, interrupt, and fast interrupt. So the exception makes ARM enter into the different modes. Now various data formats to be supported by the ARM. So there are total three formats to be supported by the ARM processor. The first one is it can perform 32-bit operations. So in case of 32-bit, it is having the ARM processor. Second is it can having data format of 16-bit. Third one is 8-bit. When it behaves to perform a 16-bit, it called as thumb mode, and when it behaves as a 8-bit processor, it indicates as Zazzle mode. Apart from these features, it also supports the high code density feature. What does it means? That it can handle the complex operations. If we have to handle the complex operations, then it has to inculcate more code. So it supports the high code density. Next is low power consumption. And no special power supply is given to ARM processors. So most of the ARM processor based machines are battery operated. Next feature is the applications or the devices which are based on the ARM processor are of smaller size. So these are the some important features of ARM processor. Now let's discuss the architecture, or we can say the core data flow model of ARM processor. So the architecture is not only characterized by its data path, but it also depends on its control path. The data path is organized in such a way that the parents are not directly fetched from the memory. It is based upon the RISC-based architecture, so the parents are fetched from the registers, but not from the memory. So here we can see that there are two typical registers, that is RM and RN. So these are the two source registers and there is one single destination registers. The more interesting facts are that there is a presence of barrel shifter. So this is the barrel shifter. What does it mean? We will discuss now. And there is one more important component, that is increment and decrement logic. Now first of all we will discuss the barrel shifter. The barrel shifter on the data path can pre-process the data before it enters into the arithmetic logical unit. So it is a basically combinational circuit that can shift a data bit to the left or to the right by an arbitrary number of positions. And one thing is more interesting, that it can process the data in the same cycle itself. So this feature is not spotted in many of the other processors. If we can compare with the classical shift register, then in case of classical shift register, the number of shifts require an equivalent number of clocks because the shifting has to take place based upon the clocks. So as we know that every operation we are performing with the help of clocks. So these clocks are even required to perform the shift operations. So in barrel shifter, combinational circuit is used where the shifting take place in a single attempt itself. In fact, the shift takes place in the same instruction itself. So this is a very basic enhancement present in the ARM data path. Now the next feature, that is increment and decrement logic, which can operate on the register that are independent of the ALU. This facilitates the implementation of auto increment and auto decrement feature in the ARM, where it is used for movement of blocks of data between the memory and registers. Now, in this flow diagram, the arrow represents the direction of data flow, and the lines represent the buses, and the boxes represent either a storage unit or we can say operation unit. So first of all, I would like to discuss instruction decoder and control. In this unit, it decodes the instruction before execution is carried out. So there are three kinds of instructions supported by the ARM core. That is a 32-bit. Second is Zazzle instruction, that is of 8-bit, and third one is thumb instruction, that is of 16-bit. So 16-bit, 8-bit, 32-bit. Now here we can see that there is a presence of 16 general purpose registers which are available to the users for programming. And from here the address will be generated. Corresponding to the address, this program counter will be incremented and next instructions will be fetched with the help of address register. So after the instruction decoding, the value of operands will come in the two registers. First one is R1, RM, and second one is RM. So these are the source registers. This will give the input to the arithmetical logical unit through barrel shifter. As we have already discussed, that barrel shifter will perform the pre-processing. Now there is one more unit, that is MAC. This MAC denotes multiplication and accumulation unit. Now it is used to help in performing the multiplication of the numbers. For example, we have to perform the multiplication of four numbers, 1 into 2 into 3 into 4. So first of all, it will multiply 1 into 2. The accumulated result will be stored into the multiple accumulation unit, that is a 2. Then 2 into 3. After that, this is a 6. 6 into 4. So this multiplication will be done with the help of multiplication accumulation unit. So after processing, there are two more units. This is for data out and this is for data in. Now discussing once again about the load and store architecture. As we know that ARM fall in the RISC category, which follows the load and store architecture, means there is a no participation of memory during processing. So registers are mandatory for processing to be carried out. Without registers, one cannot do any sort of operation with ARM core. So ARM has a two registers, that is RM and RN, and one destination register which carries the result. So the destination register indicated as RD, that is one of the registers from R0 to R15. E and B, this E, second one is B, are the two buses that will help in reading the source operands. RM and RN values will be fetched from the buses, that is E and B. and computation will be carried out in the ELU or MAC, that is a multiplication and accumulation unit. Address registers are used to hold the address, and address bus will facilitate the storage action. And this barrel shifter, which will help to do the pre-processing before execution of the operands in arithmetic logical unit. So it is a kind of a sport which is a very useful in association with arithmetical logical unit for expression evaluation and address calculation. So this is all about the architecture, or we can say core data flow model of ARM processor. So that's all. Thanks for watching.